Welcome to support activity 12B, calculating and interpreting z-score of sample means. Data collected by the Center for Disease Control and Prevention show that the average birth weight for babies in the United States is 7.17 pounds, and the standard deviation of birth weight is 1.30 pounds. So that population mean is 7.17 pounds, and the standard deviation, which is sigma, 1.30. Assume that birth weights in the United States follow an approximate normal distribution, and this distribution is approximately normal. Using the Shiny app, and we're gonna put this inputs here, bell shape for the population distribution, and enter 7.17 for the mean and 1.30 for the standard deviation. And then we try to stimulate different samples of size 5. And every time you have sample, you need to write down that what is the sample mean and the standard deviation. So let's go for basic quick, and we're gonna actually assign to Shiny app. And when we assign to Shiny app, we're gonna have to look at change that input to bell shape, and then mu that we can enter that mu 7.17, and then the standard deviation sigma, it will be 1.30. Also the size of the sample need to be changed, so that's gonna be 5. And then you're gonna do that stimulation. And according to what we have, so basic, we have here a sample size 5, and X bar for this sample is 7.36, and the standard deviation 1.39. And every time you have a different sample, you will have a different X bar and different S. Do that again, different X bar, different S. And as you see that X bar, it will actually be close to mu, and every time you will have a different value, but it's gonna be close to the sample mean, as the sample mean are actually close to the population mean. So if I go back to my activity, so basically try to answer these questions. So that part A, what is the value of the sample mean birth weight of your random sample? And what is the correct notation for this value? So remember, we use that the sample mean, we use X bar, and I already have one of my sample mean, it was 6.93. Your answer will vary or different because basic, your sample is different and your X bar is gonna be different. For part B, what is the value of the sample standard deviation of birth weight for your random sample, and what's the correct notation for this value? Every time we talk about sample standard deviation, that's mean I represent it with S. And as you see that on the top of each time you have a sample, you will have on the top here that X bar and S for this sample. And for basic this sample, I have S equal 1.19 pounds. And I have a different samples. And as you see, every time that I do that, I have a different X bar. And this is basic that some of the X bar that I have when I work with the Shiny app. And remember, your answer will be a different numbers, but I'm sure these numbers always gonna be close to the population mean. So each of these numbers is gonna be too close to the population mean. On number 3 now, compare the sample results. Are all the sample means the same? No, all basic, every time I have different sample mean. If you select another random sample of 5 babies, would it be possible to get a different sample mean? Yes, every time a new sample is taken, it is possible and likely to get a different sample mean. Because the birth weight of different babies will vary from sample to sample, the sample mean birth weight will also vary from sample to sample. The tendency of samples to have different statistics than the population as a whole due to randomness is called sampling variability. And distribution of this statistic is called sampling distribution. So you may have sampling distribution of sample means, because basic every time you will have a sample, you will get different mean. Every time you will have a sample, it's the same size, but every time you will get a different mean. So in our case, which is the sample means, if we sample from a normal population as the one seen here, the sampling distribution of the sample means will also have normal distribution. So basic, as much as you have a distribution, that's mean that we need to know the shape of this distribution. So sample means it will follow the normal distribution. So every time you will have a sample means it will be a normal shape. Also, that the mean and the standard deviation for this for the population are mu and sigma respectively. So what is the mean and the standard deviation of sample means? So we actually eventually, anytime we are having a sample means, you will actually have that in the central limit theorem that would say the mean of sample means must equal the population mean. About the standard deviation, the standard deviation will be slightly different, and it's going to be different than depend the sample size. So it's going to be equal to sigma, but it has to divide it by square root of n. So anytime you have a sample means, remember that the sample means have the same mean like the population, but I have standard deviation that different than the population one. So it's going to be that equal the population standard deviation divided by square root of n. In my case, since that population means 7.17, so the mean is going to be same for the sample means. So basic, I will have same mean 7.17. How about the standard deviation? The standard deviation, I will use that sigma, then I divide by square root of 5, since I have a sample of size 5. I have a different sample of size, different size, so you must put that number. So that number is going to be, it depends the size of your sample. So sigma over square root of 5, I get that. So recall that if I want to actually z-score for any value out of the sample means, so I will actually go back to the z formula and take that mean and subtract it from the mean for the sample mean and divide it by the standard deviation for the sample mean. So that we know from central limit theorem that mu is my sample means. So basic x bar minus mu, and then you divide by sigma, but the sigma for sampling distribution is going to be sigma over square root of n. That's why you put here sigma over square root of n. So anytime you have x bar, you must follow this formula, not the other one, the one we use it for the regular value. So every time you have a mean and you want to standardize it, you must follow this formula. Calculate the z-score of the sample mean generating question 1. In question 1 that we have the mean is 6.93. And then to standardize or to find z-score, we're going to subtract 7.17, which is the mean, and divide that by that number, which is the standard deviation for the sampling means. And now we get negative 0.41. How many standard deviation from the population mean birth weight of all babies born in the United States is the sample mean generated in question 1. So as you see, that number here is negative 0.41. So that means the sample mean of 6.93 is 0.41 standard deviation below the population mean of all baby birth weight, that's 7.17 pounds. So in question 1 to 6, you consider the following symbols. So we see that mu, x bar, sigma, and s. Which of the symbols represent a mean? Which of them represent the standard deviation? So definitely mu and x bar represent means. sigma and S represent standard deviation. Part B, which of the symbols are parameters, which are statistic? Mu and sigma, that are parameters because they describe the entire population, but X bar and S is going to be our statistic because they describe only samples. Part C, if you were to take another random sample of 5 babies, which of these symbols could change, which would remain the same? So basic for answer that we know that everything related to the sample or described sample would change. So X bar and S are statistic, so they vary from sample to sample and could change. But mu and sigma are parameters, so they are fixed value that summarize the entire population, and this value would not change from sample to sample. At the end of this activity, and we'll see you again. Thank you.